For the next part of our notes, what we're going to do is we're going to use our calculator to get through the seeding process. So, and to pick random numbers. So the first thing we're going to do is we're going to seed your calculator. Now, what the seeding process does is if as a class we all wanted to get the same random numbers, as crazy as that sounds, it allows us to do that. So what we're going to do is we're just going to pick a number to seed our calculator at, and it would be the equivalent to picking the same line in that table. You're using the same row of random numbers. So that's kind of what that is. And, you know, all the TIs, if we seed them the same way, we should all be getting the same numbers. So this is how you seed. What you're going to do, and we're just going to pick 12. You can pick any number. I just randomly picked 12. So if we go with, if we're going to seed our calculator at 12, you're going to store it. So here's the store button. And you're going to go to math. You want to go over to the probability. Okay. And you're just going to pick number 1, R-E-N-D, and hit enter. Okay. So that means our calculator has been seated at 12. Okay, so as long as you're following the steps and doing that, at any time if you want to pause and write these steps down, I encourage you to do so. It's a pretty simple process, but it's one of those things, if you don't do it a lot, it's kind of hard to remember what to go back and do. So now we're going to talk about picking random numbers using our calculator. Now, since everybody has their calculator seated at 12, we should all get the same random numbers. So for this, and I'm looking at the next problem. So you've got your worksheet. And suppose we wanted to estimate the yield of our cornfield. The field is a square and divided into 16 equally sized plots, 4 by 4, and a river runs along the eastern edge. And we want to take a sample of 4 plots. So we're going to, the first square, so if I just go back real quick here. So this right here is what we're looking at. What we're going to do is we're going to take random numbers. We're going to pick some random plots in here. And we're going to pick those numbers using our calculator. Okay, so the way that we are going to do that is you're going to go to math and you're going to go to probability across the top there, and you're going to pick option number 5, random integer. Okay, so if now I've already got some in here. I should have cleared out my calculator. But the lower is your lowest number. So our smallest plot number is 1. Our biggest plot is 16. So my upper is going to be 16. And N is like, how many random numbers do you want to pick at a time? Well, since it's telling us to pick 4 plots, I want this number to be a 4. And it's going to give me 4 random numbers at one time. Now, if you have just the TI-84, if you don't have the CE, when you get to this point right here, you're going to have parentheses. So what you want to type in is you want to type in 1, 16, 4. That's how you would type yours in. It's just the lower, the upper, and how many you want it to pick. So hit enter. So you get back out to the main screen, you'll see it's going to pop up right here. So then if we hit enter one more time, here is our random number. So 16, 5, 12, and 11. That's what everybody should get if you've all seated your calculator at 12. So if we go back to our plots, so if you've printed them, you can circle them, X them. If you're doing it digitally, you can highlight. So I'm going to highlight 16, 5, 12, and 11. I'm going to highlight all those. Okay. All right. So now it's wanting us to choose one plot from each horizontal row. Okay, so we're talking about different ways to randomly pick these plots, and what we're wanting to see is, you know, maybe does being close to the river have any effect on how much produce that they yield. So this one, we're picking one number, but we're only picking 1 out of 4 every time. Notice that they're labeled, you know, 1 through 4, 1 through 4, and so on. The horizontal rows. So what I'm going to do is I'm going to go back and I'm going to change my parameters just a little bit. So if we go back to math, go to probability, we're still going to do number 5. This time my lower number is still going to be 1, but now my upper is just going to be 4 because I'm going to pick out of each of those 4 rows. So I still want 4 numbers because I have 4 rows. If you wanted to say 1 and do this one at a time, you could certainly do that. But let's just pick 4 at a time. Okay, so that's our main screen. So here are our numbers 1, 1, 4, and 2. So in my first row, there's a 1. My second row, I pick a 1. My third row was a 4. And my last row was a 2. Okay, so then the last one that it's wanting us to randomly pick is it's doing it by column. So the strata is going to be the columns. In the first or the second one that we just did, the strata was the rows. So if I go back here, I already have, so these are my parameters that are already set. My lowest is 1, my highest is 4, and I want to pick 4 numbers at a time. So if I just hit enter, it's going to give me 4 random numbers once again. Okay. Okay, so 3, 1, 3, and 2, those are going to be what we select in our columns. So in my first column, I'm going to select 3, and then it was a 1 for this column, and then a 3, and then a 2. Okay, so which method do you think will work the best? And of course, I've already got the answer here. I should have taken that out. But so let's think about these. So I said the last method because you are guaranteed to get plots various distances from the river. Because of the way that the strata is, you know you're going to get a plot somewhere here. You're going to get a plot furthest away from the river, a little bit closer, and then you're definitely going to get a plot right up next to the river. If we have horizontal rows, you know, technically we could get random numbers of, you know, all 1s, okay? And they're all the same distance away from the river, so we have no idea, we have no way of knowing whether the proximity to the river had any effect on how much produce that the crops yielded. All right, so, and once the same thing for, you know, method number 1. You know, if they're all mixed in together, you'd randomly pick. You could get all 4 plots away from the river. You could get a nice one where they're all spread out. But the only way to guarantee that is by the vertical columns. So the last method allows you to notice any significance based on proximity to the river because each block or column is similar to the other plots in its own block. Okay, so continuing on, if we figure out what our average yield was going to be, so here's a scenario, and this is just something that was given. This is what each plot actually gave. Okay, so kind of a hypothetical situation, but let's say this is what each plot gave. So if we calculate the average yield, basically all we're doing is we're adding up the yield out of the plots that we chose and divide by 4 because we picked 4. So for the simple random sample, which was method 1, remember we had this one that was marked. So if I go back up, that same plot was marked and it had a yield of 7. And then we had this one, this one, and this one. So I add up, you know, 7 plus 92 plus 148 plus 147 divided by 4. Gave us 98.5. Okay. The horizontal strata, if I go by what the things were in that, so here is our, we had our, it should have been a 4, and I'm going to have to go and change this. A 7, a 2, and a 148. So let me go back up. Let me double check and make sure that that's what, yeah. So those were the same plots that were marked on this. So actually, this should be, so we said 7 plus, well, actually 4 plus 7. Doesn't matter the order. It's all going to come out the same. So 4 plus 7, and then a 32, and a 148. Okay, so I cheated just a little bit. I paused the video and went ahead and fixed these numbers. But so these were the numbers that we would have got for our vertical strata, and then these are the average yields based on what we got. So then graphing, you can put an X if you've got on paper. Like I said, you can just put an X or you can put a mark here, but you're just marking where the average yield falls. But we're going to skip on down to the stratified random sample. And how is it different than a simple random sample? So stratified is when you separate your items into different groups based on similar characteristics. A simple random sample is chosen in such a way that every group of n individuals in the population has an equal chance to be selected in the sample. So strata, once again, is based on, if you divide something up, boys and girls, and you're going to pick 3 boys and three girls. You're getting a good amount of each gender. Whereas if you did a simple random sample, you could randomly pick all 6 boys. So depending on what you're trying to get a sample of, that could be good or bad. So when is it beneficial to use a stratified random sample? What is the benefit, and how do you choose a variable to stratify by? So if you think about Medicare reform, so once again, this kind of refers, a good thing would be age. You may want to separate groups by age, maybe not necessarily by gender, but age would be a good one because the Medicare affects the older people. So a benefit is a more precise estimate. You want to pick the variable that is the best predictor of what you are trying to measure, which is the variable that has the strongest association.